Hey everyone, and welcome to the session on circles. This is one of the most important chapters of geometry of Maharashtra board. This is considered to be one of the difficult chapters as well. So this chapter I'm going to explain all the questions thoroughly because the maximum questions in your board examination, especially from part 2, are asked from circle, and there are ample of concepts that you already know. So before starting with the chapter, let us try to understand how many questions previously were asked from this particular chapter. So if you see this in 2020, 21, 22, 23, 24, we are talking about last 5 years. So 1 mark, you can see 2 questions of 1 mark each every year are asked. So you can expect a 2 marker here as well in the year 2025. So what can we expect in 2025? 2 questions of 1 mark. Then if you see 2 markers, again the average number of questions are 2. So even 2 markers are important. 2 questions are asked. Here if you see, only in 2022 1 question was asked, but in 2023 questions were asked, 2021 2, 2023 2, 2024 2. And again, a 3 mark is a very important question. You can expect 1 question of 3 marks. You can also expect a long question. So you can see circle has a wide range or variety of questions asked in the board examination, right? So if you see this graph as well, this gives you a good idea about how many questions of how many marks were previously asked. If you see 2021, 2022, you'll see all the different colors here. That is, the range is almost all, right? You're having 1 marker, you're having 2 marker, 3 mark, 4 mark. So that's why this chapter stands very, very important. Correct? Perfect. Now, let's begin with the questions straight away and let's try to understand the questions. We're going to solve them one by one. So here is the first question. The question says, 2 circles of radii 5.5 centimeter and 3.3 centimeter respectively touch each other externally. What is the distance between their centers? Externally means outside, right? So 2 circles, there are 2 circles of radii 5.5 centimeter and 3.3 centimeter. So can I say I have 2 circles like this, they touch externally. So this is externally touching circles. They touch over here. What is the distance between their centers? So suppose the center of the first circle is A and the center of the second circle is B. And if I join them, the radius of the first circle is 5.5 and the radius of the second circle is 3.3. We are supposed to find out the distance between their centers. So if they don't give you MCQ, in that case you are supposed to write down by theorem on touching circles, the distance between their centers will be equal to this sum of their radii. So can I say AB will be equal to R1 plus R2, where R1 is the radius of the first circle. See, I am giving you the perspective where if they don't ask you the question in MCQ, then in that case you have to write down by theorem on touching circles, AB will be equal to R1 plus R2, and that is equal to 5.5 plus 3.3, and that gives you 8.8. Correct? So is 8.8 there in the answer? Yes, it is there. So whenever they are giving externally touching, we will add the radii. If they give internal touching as in if the 2 circles are touching internally is what I wanted to say. In that case, you will subtract the radii. So if this is R1 and the inner part is R2, then the distance, this is R1, inner part is R2, then the distance between the centers will be given by R1 minus R2. In that case, you will subtract. So internally touching circles, you will subtract the radii. External touching circles, you will add the radii. Perfect? Okay, let's continue. again a 1 marker, a simple question. So ABCD is cyclic. That is, it is a cyclic quadrilateral basically. This is a cyclic quadrilateral. So ABCD is a cyclic quadrilateral and angle B is 110 degrees. We are supposed to find out the measure of angle D. So suppose there is a circle and we have a cyclic quadrilateral. Correct? So what is the meaning of cyclic quadrilateral? Cyclic quadrilateral means a quadrilateral whose all the 4 vertices lie on the circle. So suppose this is A, this is B, this is C, this is D. Correct? So ABCD is cyclic and angle B is already given. Angle B is how much? Angle B is 110 degrees. So what do we know about a cyclic quadrilateral? We know that opposite angles are supplementary. We know that opposite angles are supplementary, right? So can I say angle B plus angle D is equal to 180 degrees? Correct? Angle B is 110. So 110 plus angle D is 180. I know you can do this orally, come on. So if this was an MCQ based question, we could have easily done it. So angle D will be equal to 180 minus 110, which is 70 degrees, correct? So the measure of angle D is 70 degrees and the measure of angle B is given as 110 degrees, right? Easy, simple question. Okay, let's continue further. Now here we have an activity based question. So let's try to understand the question. The figure is also given because clearly they are saying in the figure given above. Okay, so here is the figure. O is the center of the circle. Fine, O is the center of the circle. And segment PS is a tangent segment. Correct? Segment PS. It is a tangent, isn't it? It is touching the circle at one point. And S is the point of contact. So you can see that this point S is the point of contact. And line PR, this line PR is a secant. Correct? And the value of PQ is given 3.6. So value of PQ is over here. This is 3.6. The value of PS is also given. Okay, the value of QR is given. So this QR is 6.4. We are supposed to find out the value of PS. Correct? Okay. Now understand. So this is very simple. Whenever you see a tangent and you see a secant, so tangent secant segment theorem. Let's forget about the activity. Let's solve the problem first. So this is the activity, of course. So here if I want to solve it individually, let's ignore that they have asked this in the activity part. If we are supposed to solve it, then let us see how do we do that. So we know that PS is what? PS is tangent. See, PS is what? PS is tangent. And can I say PR is secant? So according to tangent secant segment theorem, we can say that PS square, see, PS square is equal to PQ into PR. PQ into PR. So what we do is we keep PS square as it is. PQ, how much is PQ? It is there in the question, right? PQ is 3.6 into, now let's talk about PR. See, PQ is, this PQ is 3.6. This part is 6.4. So can I write down PR? can I write down PR as PQ plus QR? So this becomes 3.6 multiplied by PQ plus QR, that is 3.6 plus 6.4, that is equal to 3.6 into 10. 3.6 into 10 is 36. So can I say PS square is 36? So we have PS square is 36. So what will be PS? PS will be under root of 36, which is 6. And that is 6 centimeter, correct? So 6 centimeter is the final answer. I hope this is clear. So if you want to fill up this activity, according to the tangent secant segment theorem, PS square is PQ into PR, PQ into PR. See, there is a trick to remember this. You start from the point which is in the exterior, move towards the tangent, so PS, square it, and then again P and P, start from P only, PQ, PR, correct? So PQ is what? As it is. PI is what? PQ plus QR. PQ plus QR because of P dash, Q dash, R, P dash, Q dash, R. And then you add this becomes 10, and this becomes 36. And then once you take the square root of 36 is 6. Write down correctly the units. Okay, units are not there, so 6. Okay, unit is not there. Let's ignore centimeter. Let's write down 6. I hope this is clear to all of you. Simple question, tangent secant segment theorem. Okay, perfect. So let's have a look at a new question now. Again, it is an activity based question. So let's see what that activity is. Okay, now this is simple. So in the given figure, O is the center of the circle. Fine, O is the center of the circle. It is already given. Using given information, complete the following table. We are supposed to name the arc, and then we are supposed to measure the arc. So always remember, measure of the arc is given in degrees. Measure of the arc is given in degrees only. Okay, we are supposed to name the arc as well. So which is the minor arc? Now minor arc is arc. The measure of the arc should be less than 180 degrees. If it is equal to 180, it is semicircle. If it is greater than 180, it is major arc. So can I say angle AOB over here? Okay, wait, let's solve it here. Angle AOB is how much? Angle AOB is 100 degrees, correct? So can I say angle AOB is equal to measure of arc AXB. Angle AOB is equal to measure of arc AXB. Why? Because we know that measure of central angle, measure of central angle is equal, right? Measure of central angle is equal to the measure of corresponding arc. Right? Measure of central angle is equal to the measure of corresponding arc. Simple, isn't it? So if AOB is 100 degrees, then arc AXB is also 100. So minor arc is what? See, in this box you are going to fill arc AXB, and in this box you are going to fill the measure. Measure is 100 degrees. I hope this is clear. Now let's talk about minor arc. Okay, let's talk about major arc. Major arc is what? The arc which is greater than 180. correct? So tell me one thing, if this is 100 and the entire circle is 360, so can I say that measure of the major arc is AYB. So my major arc is going to be arc AYB. Correct? Measure arc is going to be arc AYB. And the measure of the major arc, the measure of arc AYB will be equal to the measure of the entire circle. Correct? The measure of circle minus the measure of minor arc. So that is equal to measure of the circle is 360 minus measure of the minor arc is 100, right? And 360 minus 100 is how much? 260 degrees. So 260 degrees is the actual measure of the major arc. Easy. I hope this is clear to all of you. So what are we going to write down in the second here box? In these two boxes, firstly I'll write down the major arc, that is AYB. So write down completely arc AYB, and also write down its measure, which is 260 degrees. Correct? Perfect. Let's have a look at a new figure now and a new question, of course, along with the figure. So it says, in the given figure above, M is the center of the circle. Okay, M is the center of the circle, and segment KL is a tangent segment. Okay, it's a tangent segment, and L is the point of contact. Correct? L is the point of contact. Fine. If MK is 12, so this is 12, MK is 12, KL is 6 root 3. So this is 6 root 3. We are supposed to find out the radius of the circle. Now what is the radius of the circle here? Obviously the radius of the circle is ML, right? This is the radius of the circle. Okay. So let's begin with the solution. Now we know that ML is perpendicular to KL. Why is it perpendicular? We know the relation between the radius and the tangent, right? What is the relation? The relation is that tangent is perpendicular to the radius at the point of contact. So this is 90 degrees. Tangent is perpendicular to radius, right? Tangent is perpendicular to radius. So since tangent is perpendicular to radius, can I say angle MLK is equal to 90 degrees? We can say that MLK is 90 degrees. Now since MLK is 90 degrees, can I apply Pythagoras theorem in triangle MLK? So I can say in triangle MLK, this is 12 and then this is 6 root 3. Here I have 6 root 3 and this is question mark. So I can say MK square. So I can say MK square is equal to ML square plus LK square, correct? So that is 12 square. Okay, what is the reason behind this? All of us know the reason. The reason is Pythagoras theorem. Correct. So 12 square is equal to ML square plus 6 root 3 the whole square. So this is 144 is equal to ml square plus 6 root 3. 6 square is 36. Root 3 square is 3. So this becomes 36 into 3. So can I say 144 is equal to ml square plus 108. So if this goes on the other side, can I say ml square is equal to 144 minus 108, that is ml square is equal to 36. Now if I take square root on both the sides, ml will be equal to under root 36, and under root 36 is nothing but 6. Is it in centimeters? We need to check. No, it's not in centimeters. So yes, we'll keep the final answer as it is. So the radius, ml itself is the radius, right? So the radius is equal to 6 units. I hope this question is clear to all of you. You've understood this basic Pythagoras theorem. What was the concept used here? The concept was tangent is perpendicular to the radius at the point of contact. Tangent and radius, they are always perpendicular, please remember. Correct? Okay, let's continue. So here we have a new question. Okay, so this is a proof which is very simple. This was asked in the year 2020 and we are supposed to prove that tangent segments drawn from an external point to the circle are congruent. So if we just break this down, tangent segments drawn from an external point. External means outside, right? Outside. That is point outside the circle. So if we have a circle, let's say we have point P. So this is A, this is B, and suppose we have a point that is point O, right? So what is given? It is already given that there are two tangent segments. See, we have to always go slow when it comes to proving. We'll start with given. So what is given? Tangent segments are drawn from the external point. So point P is given. You can say point P lies in the exterior, right? Point P lies in the exterior of the circle. Correct? And it is already given PA and PB are tangent segments. Correct? PA and PB are tangent segments. Now since PA and PB are tangent segments, we are supposed to prove that PA is equal to PB. Correct? We are supposed to prove that PA is equal to PB. Okay, for that we will do a construction. Construction is we'll join OA, we'll join OB, and we'll join OP. Right? So that is our construction. So construction is three things we are joining: OA, OB, and OP. So I'll write down join OA, OB, and OP. Now once we have joined this, how does our figure look like? Okay, the figure was already there, but since we have drawn, let us stick to our figure now. So this is OA, OB, OP. So we have a circle, we have a point, that is point P. We have the center, so it's like this. This is A, B. Okay. Now let's begin with the proof. Can we prove the two triangles congruent? Let us see. So let's prove the two triangles congruent. So I can say in triangle OAP and triangle OBP, in triangle OAP and triangle OBP, can I say angle A is equal to angle B? See, these two angles are going to be equal, right? This is 90, this is 90, because tangent is perpendicular to the radius at the point of contact. This is 90 degrees each. This is each 90 degrees. And what is the actual reason? The reason is tangent is perpendicular to radius. Correct? Now, can I say OA and OB are equal? Can I say OA is equal to OB? Yes, because both of them are radii of the same circle. So I'll write down radii, right? Radii of same circle. So OA is equal to OB. And then can I write down this common side? There is this common side over here, that is OP. So I can write down OP is equal to OP. That is called as common side. Correct? Now understand, if you see this very carefully, see the markings. We have 90 degree, we have one side, and we have hypotenuse. So can I say the two triangles are congruent by hypotenuse side theorem? So the two triangles are congruent by hypotenuse side theorem, right? Therefore, the two triangles, triangle OAP is congruent to triangle OBP by hypotenuse side test or theorem, you can say. You can also write down test. Hypotenuse side test is also fine. Correct? So the two triangles are congruent now. Since the two triangles are congruent, now can I say this PA and PB will be equal? So we will write down PA is equal to PB. PA is equal to PB. And what is the reason for this? Why PA is equal to PB? PA is equal to PB because of corresponding sides of congruent triangles, CSCT. And that's it. What does this mean? This means that the length of the tangent segments drawn from the external point to the circle are always equal. That means these two lengths, that is PA and PB, are equal. Correct? Which are the tangents drawn from the external point. I hope this is clear to all of you. Perfect. Let's continue. Let's have a look at a new question now. It says, circles with centers A, B and C touch each other externally. So circles with centers A, B and C touch each other externally. If AB is 3 cm, BC is 3 cm, CA is 4 cm, then find the radii of each circle. So in this question, clearly they are giving AB, BC, CA. That means the figure will be given to us. So the figure will look something like this. Up to this, I guess it is clear. So there are three circles. Circle with center A, circle with center B, and circle with center C. So circle with center A, circle with center B, and circle with center C, all three of them are touching externally. So A and C is actually touching over here. B and C, circles with center B and C are touching over here, and circles with center A and B are touching over here, right? If you want, you can also take it as EF, DEF, something like this. You can take this as D, you can take this as E. That's your choice, it's not compulsory. Okay. Now what they are saying? They are saying find out the radii of each circle. Now this is very simple, isn't it? Understand how to do this. Firstly, what is AB given? AB is given, right? AB is given as 3 centimeter. So if AB is 3 centimeter, can I say AD plus DB? AD plus DB is equal to 3. But AD is R1 and DB is R2. So R1 plus R2 is 3. Simple, isn't it? R1 plus R2. This entire part will be 3. Now observe here, R1 plus R3. So can I say AC? This time I am doing it directly. What will be AC? AC will be AF plus FC. So can I say this implies R1 plus R3 is equal to AC is 4. R1 plus R3 is 4. I hope this is clear. And then finally you have R2 plus R3, correct? That is BC. BC is equal to BE plus CE. But BC is how much? BC is 3. So R2 plus R3 is 3. So this is 4. This is 3. So whatever I have underlined here, these are the 3 important results for us. So we're going to use these results to find out the values of R1, R2, R3. Okay, let me just write it down first. So what do I have? I have R1 plus R2 as 3. So R1 plus R2 is 3. Then R2 plus R3. R2 plus R3 is also 3. And then R1 plus R3 is 4. Now let me add them. R1 plus R1 is 2R1 plus R2 plus R2 is 2R2 plus R3 plus R3 is 2R3, that is equal to 3 plus 3 plus 4. Can I say this will become 10? 3 plus 3 is 6, 6 plus 4 is 10. So from here can I take 2 common? If I take 2 common, I get R1 plus R2 plus R3 is 10. You can divide 2 now. So if you divide 2, you get R1 plus R2 plus R3 is equal to 10 divided by 2. That is 5. Okay. Now understand. R1 plus R2. You already have R1 plus R2 here. 3. So what if I put R1 plus R2 as 3? So can I say 3 plus R3 is 5. So 3 goes on the other side. So I get R3 is equal to 5 minus 3, that is 2. Correct? Similarly, in the same equation, what I'll do is, I'll put R2 plus R3. I'll put R2 plus R3 as 3. So if I put this as 3, I have R1 plus 3 is equal to 5. So this goes on the other side. So can I say R1 is going to be 5 minus 3. That is, okay, 2 again. And then finally, R1 plus R3 is 4. R1 plus R3, this is 4. So can I say 4 plus R2 is 5? Okay, R1 plus R2 plus R3 is 5. This we already have. But R1 plus R3 is how much? R1 plus R3 is 4. So I can say 4 plus R2 is 5. So what will be R2? R2 will be 5 minus 4, which is 1. So R2 is 1, R1 is 2 and R3 is 2. Let us check. R1 2. So 2 2. R3 2. So this is 2 2 and R2 is 1. This is 1 1. 2 plus 1 3. 2 plus 2 4. 1 plus 2 3. So our answer is correct, right? Because the entire length was already given to us. So we have just plugged in the values and checked. Perfect. Okay, let's continue further. So this is an MCQ based question. It's a very simple question. Angle PRQ is inscribed in the arc PRQ of a circle with center O. If PRQ is 75 degrees, then what is measure of angle PRQ? Okay, so basically they have not given the figure. So figure we need to figure out. PRQ is an inscribed angle. Now suppose we have a circle. PRQ is inscribed. So PRQ. So PRQ is inscribed, right? And this is the center O. And please understand this question very carefully. PRQ is inscribed. That means point R lies on the circle. Correct? In the arc PRQ, obviously the arc will also be PRQ. If PRQ is 75 degrees, so this angle PRQ, this is 75 degrees, then what is the measure of arc PRQ? Okay, interesting. Now see, if I take a point over here, say for example X, we know that by inscribed angle theorem, PRQ, angle PRQ will be equal to half of measure of arc PXQ. So can I say the 75 is equal to half of measure of arc PXQ. So 2 goes here. So 2 into 75 is 150. So 150 is equal to measure of arc PXQ. So this arc PXQ is 150 degrees. But don't make a mistake. Many of the children, they'll write down 150 degrees. No, 150 is what the intercepted arc. So what will be this inscribed arc over here? The inscribed arc is the remaining arc. So we are talking about this part. So from the entire circle, we are supposed to subtract that, isn't it? But the remaining arc, that is arc PRQ, the measure of this is going to be 360 minus 150, and that is nothing but 210 degrees. So option D is the correct option. See, although it was asked for 1 mark, but if they don't give this question in MCQ, you can directly do this by solving here by inscribed angle theorem. Measure of the inscribed angle is half the measure of the intercepted arc. Correct? Perfect. Let's have a look at one more question. Again, it is a very short question. So it says radius of the circle with center C is 6 cm. So there is a circle with center C, the radius is 6 cm, and line AB is tangent at point A. What is the measure of angle CAB? This is not an MCQ. We're supposed to find out the measure of angle CAB. Radius of circle with center C, radius is 6 cm. That means CA is given. And AB is a tangent. AB is a tangent at point A. So point A is definitely the point of contact, right? This is your POC. Question says, what is the measure of angle CAB? This angle. Now see how they are tricking you. They are giving you the value of CA. They are giving you the value of radius. But they are asking you the angle. So radius is not needed here. Even if we don't know the value of the radius, we can still find out the angle CAB here. So can I say CA, how do I write this? CA is the radius. CA is the radius. We start like this. And BA is the tangent. So can I say CA is perpendicular to BA. And what is the reason? The reason is tangent is perpendicular to radius, correct? At the point of contact. So CA is perpendicular to BA. So can I say angle CAB? Angle CAB is equal to 90 degrees. Perpendicular means 90 degrees, no? And anyways, you know the theorem, the tangent is perpendicular to the radius at the point of contact. So anyways, this is going to be 90 degrees. So the value of the radius that is given, which is 6 centimeters, is of no use for us. Even if we don't know what is radius, we can still find out and say that the measure of angle CAB is 90 degrees. I hope this is clear to all of you. Perfect. Let's continue. Now let's have a 2 marker. Okay. So in the circle with center O, so there is a circle with center O, the length of chord AB is equal to the radius. Complete the following activity to find out the measure of angle AOB and measure of angle ACB. So let's not see the activity. Let's solve the problem first. Correct? So we are supposed to find out the measure of two angles. One is angle AOB. Second is angle ACB. Okay, now understand. What is given? Chord AB, right? It is given that the length of chord AB is equal to radius. Can I say this is given? That was the very first line. So can I say this chord AB is equal to OA and OB? Correct? Chord AB is equal to OA and OB. This is given. So can I say this triangle AOB is equilateral? So triangle AOB is equilateral, right? Now since triangle AOB is equilateral, what is the measure of each angle of equilateral triangle? So can I say angle AOB is 60 degrees. So we got one answer. Angle AOB is 60 degrees. AOB, this. See, now we know one thing, that AOB is central angle. Angle AOB is central angle and angle ACB is inscribed angle. AOB is central, ACB is inscribed. So can I say angle ACB is half of angle AOB. Angle ACB is half of angle AOB. So can I say this is half of AOB? AOB is 60 degrees. So can I say this becomes 30 degrees? So we got the answer. That is exactly what we needed. This angle over here is 30 degrees, correct? So if we fill in the boxes here, angle AOB directly, it is an equilateral triangle. So what is the measure? We are supposed to write down the measure here. That is 60 degrees, correct? ACB is half of AB. We are supposed to write down the reason here. What is the reason? Inscribed angle theorem. Inscribed angle theorem. So write down inscribed angle theorem. So ACB is what? Half of 60. Half of 60 is 30. So this becomes 30. Correct? I hope this is clear to all of you. Simple question. Let's continue. So here is a new question. This was asked previously for 2 marks in the year 2021. Very simple question. So measure of two arcs formed by a chord. Measure of two arcs formed by a chord of a circle are 2x and 7x degrees respectively. Find the measure of minor arc. Okay. So definitely you need a circle, right? You need a circle. Have a chord. Now this chord is subtending a smaller arc whose measure is 2x degrees and a larger arc whose measure is 7x degrees. We are supposed to find out the measure of minor arc. Okay. So suppose this is A and this is B and this is say C and this is D. So basically we can define first. What can we define? We can define the arcs here. We can say let AB be the chord, right? AB is the chord. Arc ADB. Arc ADB is minor and arc ACB is major, right? Now tell me one thing, what will happen if I add both the arcs? If I have this arc and then if I have this arc and if I add both of them, what will happen? Can I say arc ADB, that is the measure of this, plus the measure of arc ACB gives you the complete circle, right? That is 360 degrees. So once I add them, I get 360. So measure of arc ADB, can I say this is 2x? Can I say this is 7x? So this becomes 9x is equal to 360. And once we get 9x is equal to 360, can I say x is equal to 360 by 9? So x will be equal to 40 degrees. Now is x is equal to 40 the final answer? No, it is not the final answer. We needed the minor arc. So let's ignore 7x. Let's focus on 2x only. That gives you 2 into 40. And that is 80 degrees. So the measure of the minor arc is 80 degrees. And the measure of the major arc, if they ask you, although they have not asked it, that is 360 minus 80, which is 280, or else 7 fours are. Directly you put 40 here, 7 fours are 28, so 280 is the answer. Correct? Okay, now we have an activity based question. So what is given? It is given that in the figure above, or say below here, for an instance, circles with centers x and y. Circles with centers x and y. Okay, so here the center is x. Just interchanging this, nothing much. This is y and this is z. Okay. Circles with centers x and y. This is x. This is y. Touch each other at point z. Okay, perfect. So the figure is right now. Touch each other at point z. A secant passing through z, like this, the cross secant, intersects the circles at points A and B respectively. So you can see here, point A is here, point B is here. It intersects like this. And then we are supposed to complete the following activity to prove that radius XA is parallel to BY. See, this is very simple, isn't it? We are supposed to prove that the two radii are parallel. So let us see the activity. Now understand, obviously we are going to prove this further as well. So if you see this very carefully, what is given to us? It is given that there are two circles. Okay. X is the center of the first circle, Y is the center of the second circle, Z is the point where they are touching. So by theorem of externally touching circles, X, Z, Y, what can I say about X, Z, Y? It is very important. X, Z, Y. X, Z, Y. Can I say they lie on the same line? They lie on the same line. So what are you going to fill here? You should know the term for that. When we know that 3 points lie on the same line, they are called as collinear. Collinear. Correct? XZA. Now understand. So can I say XZA is equal to YZB, this angle and this angle, right? That's what we call it as vertically opposite angles, right? So XZA is equal to YZB, correct? That goes here. Now we already know that XA is equal to XZ, right? XA and XZ are equal. What is the reason for that? Can I say we can write down the reason as radii of the same circle? Radii of same circle. So by isosceles triangle theorem, if the two sides are equal, understand, in a triangle, if the two sides are equal, then can I say these two angles are also equal? So angle XAZ is equal to angle XZA. Now can we apply the same concept there? Let's see. So again I am changing this. This is our Y and this is our Z. Okay. So we know that YB and YZ, we know that YB and YZ, they are equal. So YB and YZ are equal, then again I can apply isosceles triangle theorem. So can I say BZY, this angle, is equal to this angle by isosceles triangle theorem. So now can I say XAZ? Okay, now this is a confusing step. So I'll just write it and break it down for you. Understand? See, what was the result? We got result angle XAZ. XAZ was equal to XZA. Then we know that YBZ and YZB or BZY, BZY is equal to YBZ. This we already have. This is from the previous page and this we already have. Now we already know that this angle and this angle are equal. They are vertically opposite angles. That is XZA. XZA and BZY. These two angles are already equal. So now can I say that XAZ and YBZ, XAZ will be equal to YBZ. So this will become angle YBZ, correct? Now understand, still it is not completed because if you see, so XAZ, Z is here by the way and Y is here. So this angle XAZ is equal to YBZ. So there are two lines like this and there is a line like this. Here is A, here is B, this is A, this is B, and these two angles are equal. So can I say this line and this line will be parallel now, because if the alternate interior angles are equal, the lines are parallel. So what is the reason that you're going to write down? See, if the lines are parallel, alternate angles are equal. That is alternate angles theorem. Here the angles are equal, therefore the lines are parallel. So you'll write down converse of alternate interior angles. Converse of alternate interior angles theorem, correct? That is converse. If the angles are equal, then the lines are parallel, right? So this way we have proved it. So let's continue further with a new question. It says ABCD is cyclic. Okay, cyclic quadrilateral. I hope you remember what is a cyclic quadrilateral. A quadrilateral whose all the four vertices lie on the circle is a cyclic quadrilateral. AB is equal to AD. Okay, perfect. So the figure is given. AB is equal to AD. Angle BCD. Angle BCD. This angle is 70 degrees. We are supposed to find out three values. Measure of angle BCD. Arc BCD. Okay. So this complete arc. Correct. Then measure of angle BAD. So angle BAD is over here. Correct. And then we are supposed to find out the measure of angle ABD. ABD. Okay. First thing first. So let's take one thing at a time. Let's talk about measure of angle BCD. Measure of arc BCD. Okay. So this is a cyclic quadrilateral, right? So firstly I can say that quadrilateral ABCD is what? This is cyclic. Quadrilateral ABCD is cyclic, correct? So since ABCD is cyclic, can I say opposite angles of a cyclic quadrilateral are supplementary? So angle A, or in short I can say angle BAD plus angle BCD will be equal to 180 degrees. What is the reason? The reason is opposite angles of cyclic quadrilateral are supplementary, right? So opposite angles of a cyclic quadrilateral are supplementary. So angle BAD is as it is. And angle BCD, that is 70. And that is equal to 180 degrees. So if I take 70 on the other side, can I say angle BAD is equal to 110 degrees. So this angle BAD is 110 degrees, but that is not asked in the question. But now that is going to help us further. See how. So this BAD is 110, but we know that in a circle, the inscribed angle is half of the intercepted arc. So here BAD is an inscribed angle. So now can I find out this entire arc BCD? I can say that measure of angle BAD is half of measure of arc BDC or BCD. This is because of inscribed angle theorem. Correct. But BAD is already 110, so can I say 110 is equal to half of measure of arc BCD. So 2 goes that side, so I get measure of arc BCD is equal to 110 into 2, that is 220 degrees, right? So 220 degrees is the measure of this arc, correct? So right now we have just got one value. Okay, no problem. Now let's continue further. We are supposed to find out measure of arc BAD. Now see, if this BCD is 220 degrees, how much will be the remaining? Obviously, we'll subtract that from the circle, correct? Or else we have one more way of doing this. This angle is the inscribed angle. So this will be half of BAD. So if this is 70, that will be double. Double is 140. Okay. So here can I say further that measure of arc BAD is equal to measure of circle minus measure of arc BCD. So that gives you 360 minus measure of arc BCD is 220, and that is going to give you 140 degrees. Correct? So this upper part, this is 140. Still the question is not over, because the third question says we are supposed to find out the measure of angle ABD over here. How do we do that? Now understand, it is already given that AB is equal to AD, correct? Therefore, can I say measure of minor arc AB is equal to measure of minor arc AD. So can I say this arc and this arc, both of them are equal. This can be x, this can be x. Correct? So let them be x, right? Because both of them are equal. Now we already know that measure of BAD, measure of arc BAD is equal to, see, BAD will be what? AB plus AD. So this is further equal to x plus x, and BAD is how much? BAD is already we have calculated 140 degrees. So I can say 2x is equal to 140. So x will be equal to 140 divided by 2. So can I say x will be equal to 70 degrees. Correct? So the value of x is 70 degrees. So this is 70, this is 70. Now understand. Now we have a circle and we have this angle ABD. We have A, we have B, we have D. Correct? So what will be this angle? Can I say this will be half of the intercepted arc by inscribed angle theorem, and if this is 70 degrees, this angle is half of 70, which is 35 degrees. So now can I say that angle ABD is equal to half of measure of arc AD. What is the reason? The reason is inscribed angle theorem. So angle ABD is half of 70. Half of 70 is how much? 35 degrees. So can I say this angle over here will be 35 degrees? Easy, clear, simple. So we have got all the values, isn't it? Angle ABD, they asked us, this is 35. Initially they asked us BCD, the measure of this entire arc. We had 70. This became 110. Double of this become 220. So this becomes 220. And then BAD. BAD is remaining. That becomes 140. Correct? Perfect. So let's begin with a new question now. It says, an interesting question. If two consecutive angles of a cyclic quadrilateral are congruent, two consecutive, not opposite. That means they are adjacent. Then prove that one pair of opposite side is parallel and the other pair is congruent. Okay. So this is how the figure looks like, but let me structure the figure for you. We'll use that later. So two consecutive angles of a cyclic quadrilateral are congruent. So firstly we need a cyclic quadrilateral. The figure should look like this, a circle. Firstly we need to have a circle. Then we need to have a cyclic quadrilateral. So definitely there should be a quadrilateral inside it. Something like this. We'll use the namings later from there, but I'm telling you the meaning of this. So what they're saying is, what are the opposite angles here? A and C are opposite, B and D are opposite. Opposite are equal is not given here. What is given? Consecutive. So you can take A and D, you can take D and C, you can take B and C, you can take A and B. But because we have structured like this, let us take D and C equal. So what they are saying, if these two angles are equal of a cyclic quadrilateral, we are supposed to prove that one of the pair of opposite sides is parallel. So we are supposed to prove that these two are parallel, that is AB is parallel to DC first, and second we are supposed to prove that the other pair is congruent. That means we are supposed to prove that this AD and BC are equal. So this is what we are supposed to prove, AD and BC equal, AB and DC parallel, and then for this we will do a construction, that is we'll draw 90 degree, prove the two triangles congruent, and then that becomes easy later. So here is the figure, correct? So what is given? Let's go slowly because this is a 4 marker. You have to give all the steps correctly. What is given? It is given that quadrilateral ABCD is cyclic, right? Quadrilateral ABCD is cyclic. This is given. Okay, so what are we supposed to prove? We are supposed to prove that one pair is parallel, that is AD is parallel to BC. This is what we are supposed to prove, and the other pair is congruent, that is AB is equal to DC. So these are the two things that we are supposed to prove. But one important fact is given. What is that? Two consecutive angles are equal. So here, apart from cyclic, it is given that angle B and angle C are equal. Angle B is equal to angle C. This is given. Correct? Okay. So what is our construction here? We are going to construct something. What is our construction? Our construction is basically to draw perpendiculars. So we are going to draw AM. You can see those dotted lines, right? AM perpendicular to BC. And then we are going to draw DN perpendicular to BC. Correct? Okay, so now let us try to prove the first part, that is one pair of opposite sides is parallel. Let's try to prove that. So we are proving AD parallel to BC. Let's target this. Now understand, this is a cyclic quadrilateral. So since it is a cyclic quadrilateral, can I say quadrilateral ABCD is cyclic, therefore angle DAB, that is this angle, entire angle, plus angle DCB or BCD, angle BCD is equal to 180. What is the reason? The reason is opposite angles are supplementary. Correct? Okay, so the opposite angles are supplementary. But tell me one thing, it is already given that this angle C is equal to this angle B. So firstly, can I write down angle DCB is equal to angle ABC is already given. Therefore, from here I can say angle DAB plus, instead of BCD, this is BCD, same thing, BCD, BCD, plus angle ABC is equal to 180. We have replaced BCD with ABC. Now observe, this angle plus this angle is 180. So we have two lines, we have like this plus this is 180. We know that if co-interior angles are supplementary, the lines are parallel. So can I say here, therefore AD is parallel to BC. This is because of, since the co-interior angles are supplementary, lines are parallel. You can also write down this as the converse of interior angles theorem, right? Interior angles theorem, because the angles are equal, angles are supplementary, the lines are parallel. So this is the first part, we have proved it, that AD is parallel to BC. Now we are supposed to prove the second part, that AB is equal to DC. So what are we supposed to prove? We are supposed to prove AB is equal to DC. For that, what we will do is, we'll pick up the two triangles separately. So this is a triangle, this is on the other side, this is your A, this is your B, this is your M, and then this is your D, this is your N and C, this is 90, this is 90, because that's what we have constructed. So can I say, firstly, in triangle AMB and the other triangle is DNC, can I say angle AMB is equal to angle DNC, because both of them are 90 degree each, correct? Then can I say here angle B and angle C is equal? Angle ABM is equal to angle DCN, because this is given, correct? Now understand, these two lines are parallel. Which two? AD and BC are parallel. We have already proved that. So can I say perpendicular distance between the two parallel lines is always equal? If there are two lines parallel to each other, then the distance between both of them, you draw infinite lines here. All the distances are going to be equal. So can I say AM will be equal to DN? What is the reason? The reason is perpendicular distance between two parallel lines. Now observe this, observe the pattern. What all did we get? We got this and this equal, then this angle and the third angle. So can I say we have a side, we have angle, we have one more angle. So the two triangles are congruent, right? So triangle AMB is congruent to triangle DNC because of side angle test. And since the two triangles are congruent, now can I say that AB is equal to DC. Therefore, AB is equal to DC. right? AB and DC will be equal. Corresponding sides of congruent triangles are equal. This is the reason. Perfect. So I hope you have understood this question. By corresponding sides of congruent triangles, we got AB is equal to DC. Before that, we have already proved AD parallel to BC. Correct? Perfect. Let's continue further. So we have a one marker. It says AP is a tangent drawn at A. AP is a tangent at A, drawn to a circle with center O from an external point P. OP is 12, angle OPA is 30 degrees, then what is the radius of the circle? Okay, so there are options. Figure is not given, but no worries, we can draw the figure. So there is a circle basically, there is a circle, and AP is a tangent at A. AP is a tangent at A. This is A, this is P. Correct? AP is a tangent at A drawn to a circle with center O. So O is the center of the circle. OP is 12. So from O to P, this part is 12 centimeter, and angle OPA, this angle, this is 30 degrees. We are supposed to find out the radius of the circle. We are supposed to find out the radius of the circle. Now see, it is very simple. Firstly, we know only one value, that is OP. So definitely we cannot apply Pythagoras theorem here. See, Pythagoras theorem you can apply when you know two values and you find out the third value. But here we need to apply trigonometry, right? So can I say in triangle OAP, firstly, if I talk about in triangle OAP, angle A is already 90 degrees, correct? So this is a right angle triangle, right? And now angle P is 30 degrees. What do I need to find out? I need to find out the radius. So here, can I say for 30 degrees, OA is the opposite side and OP is the hypotenuse side. So now we know that opposite by hypotenuse, that is sine. So can I say here further, sine theta is opposite by hypotenuse. Theta is 30 degrees. So there I am taking sine 30. Sine 30 is opposite. Opposite is OA. Hypotenuse is OP. So sine 30 is 1 by 2. So 1 by 2 is equal to OA, which we don't know, by OP, which is 12. So 12 goes on the other side. So can I say OA will be equal to 12 by 2 and OA is going to be 6 centimeter. So 6 centimeter is the correct answer. I hope this is clear to all of you. AP was a tangent at point A. OP is 12. Angle OPA is 30 degrees. We are supposed to find out the radius. So for radius, this is the opposite and the hypotenuse. We use sine theta. Sine theta is opposite by hypotenuse. So this becomes, sine theta is 1 by 2. So 1 by 2 is equal to OA by 12 and then you solve it further. A simple question asked for 1 mark. Perfect. Let's continue further. So here we have one more question of 1 mark. It says chord AB and chord CD of circle with center O are congruent. If measure of arc AB is 120 degrees, then find the measure of arc CD. This is a very simple and a straightforward question. See, circle is there and there are two chords, chord AB, chord CD. Chord AB and then you have chord CD. Correct? So chord AB and chord CD are the two chords with center O and they are congruent. Chords are congruent, right? So it is already given that chord AB is equal to chord CD, right? So chord AB and chord CD are equal. Measure of arc AB is given. How much? 120 degrees. We are supposed to find out measure of arc CD. Do we even have to do anything? No. Directly it is 120 degrees. We just need to present it correctly. Therefore, we will say measure of arc AB is equal to measure of arc CD. Why? Because we know that congruent chords subtend congruent arcs. So reason is congruent chords subtend congruent arcs, right? So can I say therefore measure of arc CD will also be equal to 120 degrees. So 120 degrees is the measure of arc CD, but don't write it down in one word or just write down the final answer. Give a proper reason, because this is geometry. You have to give reason for every statement that you write, correct? Alright then, we have a 2-mark question. Let's understand this question. It says, in the above figure, measure of arc DXE is given, that is 105. Then measure of arc AYC is also given, 47. We are supposed to find out the measure of angle DBE. This angle we are supposed to find out. Now this is an interesting and a simple question. See, there are multiple ways of doing this. Firstly, what you can do is, you can join AE. So what you can do is, you can join AE this can be your construction part. Now understand, measure of arc DXE is already given. How much is that? That is 105 degrees. This is 105. So can I find out this angle? Can I say angle DAE? Can I say angle DAE is half of measure of arc DXE. So that is half of measure of arc DXE is 105. So I'm writing down 105 here. So that is equal to 105 by 2 degrees. This is what? This is this angle. Now if I look at the other way around, this part, this will be half of this angle, arc. AYC is already given. I guess that was 47. Okay, 47. So can I say angle AEC is half of measure of arc AYC. So can I say AEC will be half of 47, that is 47 by 2 degrees. So this angle is 47 by 2 degrees, right? Now understand. Now this is 105 by 2 and this is 47 by 2. Now we know that by exterior angle theorem, exterior angle of a triangle is equal to sum of its remote interior angles. This is the exterior angle, that is 105 by 2, and this is one of the remote interior angles, that is 47 by 2. So now we can say that by remote interior angle DAE is equal to angle ABE plus angle AEB, correct? So DAE, but DAE is 105 by 2. ABE plus AEB is 47 by 2. So that gives you ABE is equal to 105 by 2 minus 47 by 2, correct? So that is 105 minus 47. How much is 105 minus 47? So this is 8, correct? And 5, so 58 by 2, and that gives you 29 degrees. 29 degrees is the final answer to find out the measure of angle ABE. ABE and DBE are same. So DBE is equal to 29 degrees, right? I hope this is clear to all of you. Simple? Okay. Is there another way of doing it? Yes, there is another way of doing it. There is a direct formula, right? So what is the direct formula? This is given. This is given. If the chords meet in the exterior of the circle, then the angle formed between the chords is the difference of the two corresponding arcs. Half of the difference of the two corresponding arcs. That means angle DBE is directly equal to half of measure arc DXE minus measure arc AYC. That is equal to half of measure arc DXE is 105, measure arc AYC is 47. You just take half and subtract them. 105 minus 47 is 58, and half of 58 is 29 degrees. And that's it. You can also find it in this way. Please make a note of this formula. So once you know this formula, the question becomes very easy, right? Perfect. Let's continue further. Okay. So here we are supposed to verify something. In the figure, chords PQ and RS intersect each other at point T. Okay. If STQ, this angle is 58 degrees, okay. This is 58, and PSR, this is 24 degrees. Complete the following activity to verify that the measure of angle STQ is equal to half of measure of arc PR plus measure of arc SQ. Correct? So this is what we are supposed to verify. So firstly, let us talk about the triangle. So in triangle PST, or let's forget about the activity here. Let's focus only on this part. So what is given? We have the value of this angle STQ. STQ is 58. This is 58. Correct? Then we have this as 24. So what we will do is, firstly, we can see that this particular angle, right, this angle is the exterior angle. If this is 58, this is the exterior angle for this triangle. So if I have this as 24, can I find out SPT? Yes, I can do that. Can I say here, by remote interior angles theorem or exterior angles theorem, that's your choice, you can say that angle STQ is equal to angle PST plus angle SPT. So this is 58. 58 is equal to, so 58 will be equal to 24 plus, see this is 24 plus angle SPT. So if I shift 24 there, can I say angle SPT is equal to 58 minus 24, and that is equal to 34 degrees, correct? So SPT is 34. Now understand, if this is 34, this is 34. Now tell me one thing, this is an inscribed angle, so how much will be this? Can I say arc SQ? Arc SQ, anyways this is an activity based question, so we are going to fill the activity. So measure of arc SQ will be 34 multiplied by 2, that will become 68, because we know that by inscribed angle theorem this angle is half of this, so this arc is double of this angle, so this is 68 degrees, correct? Similarly, if you see this angle, angle PSR is 24 degrees. So can I find out measure of arc PR? Can I say measure of arc PR will be how much? 24 into 2, that is 48 degrees. Now what will happen if I add both of them? If I add them, I get measure of arc SQ plus measure of arc PR. That will be equal to 68 plus 48. That is equal to 116 degrees. This is 116 degrees, and here if you see, if I multiply this by half on the left and if I multiply by half on the right, can I say I get 58 degrees? And 58 degrees is nothing but this angle STQ. So yes, we have verified that measure of angle STQ is half of measure of arc SQ plus measure of arc PR. I hope this is clear to all of you. Now let's have a look at the activity and let's try to fill this. So this is what we are supposed to verify, right? So for that, firstly we took triangle PTS. In triangle PTS, angle SPQ, this angle, is equal to angle STQ minus angle PST. So here you will have angle PST. So that is 58 minus 24. This was 58. This was 24. 58 minus 24 is 34. So this angle over here is 34. Then measure of arc QS, correct? This arc QS is double of 34, which is 68 by inscribed angle theorem. Similarly, measure of this arc PR will be double of this, double of 24 is 48 degrees, correct? And then after that, you can just add them, right? So 68 plus 48 is 116, and half of it is 58 degrees, right? So that's it. So from 1 and 2, we can say that, see, this is 58, this is 58. So from 1 and 2, the left hand sides are equal. So that is half of arc PR plus QS is equal to angle STQ, correct? Perfect. So we have solved this part. and then, okay, this is not needed, we have already proved it, that's it. This is from the previous slide. So we are done with it. Let's continue further. So now we have a proof. We are supposed to prove that the opposite angles of a cyclic quadrilateral are supplementary. Now this is a very simple proof. Opposite angles of a cyclic quadrilateral are supplementary. So what do we need? Let's figure that out. Firstly, we need a cyclic quadrilateral. For a cyclic quadrilateral, we need a circle. So we need a circle. So we have A, B, C, D. So what is given to us? What is given? It is given that we have a cyclic quadrilateral. So we can say quadrilateral ABCD is cyclic. Correct? ABCD is cyclic. We are supposed to prove that. What are we supposed to prove? We are supposed to prove that the opposite angles are supplementary. That is, we are supposed to prove angle A plus angle C is 180, and we are supposed to prove that angle B plus angle D is also equal to 180 degrees. This is what we are supposed to prove. Correct? This is very simple. Now, so firstly, can I say angle B is D, angle BAD. Angle BAD is an inscribed angle, correct? This is an inscribed angle. So can I say angle BAD, measure of angle BAD will be half of the measure of arc BCD, correct? Ideally, we don't need that figure. So let's continue with our figure only. So can I say measure of angle BAD, measure of angle BAD is equal to half of measure of arc BCD. So if you see our figure, so here we had a cyclic quadrilateral, correct? So this is A, B, C, D. So this is the angle, right? So measure of angle BAD is half of measure of arc BCD. And what is the reason for this? The reason is inscribed angle theorem. You can also name this as your equation number 1. Similarly, if I talk about this angle, that is measure of angle BCD, can I say measure of angle BCD is equal to half of, now BCD will be half of this, correct? Will be half of measure of arc BAD. What is the reason? The reason is again inscribed angle theorem. I'm marking this as statement number 2. Now what if I add both of them? So if I add the two statements here, that is statement number 1 and 2. So I'm saying adding 1 and 2. Adding 1 and 2, we get measure of angle BAD plus measure of angle BCD is equal to, this is half, this is half, so half of measure of arc BCD plus half of measure of arc BAD. So that is equal to half of measure of arc BCD plus, so this is measure of arc BCD plus measure of arc BAD. Now understand. Now what is BCD plus BAD? BCD plus BAD. Can I say BCD plus BAD is 360 degrees because that completes a circle. So this becomes half of 360, right? So can I say this is further equal to half of 360 degrees, and that is equal to 180 degrees. So we have proved that angle BAD plus angle BCD, this one, angle BAD plus angle BCD is how much? It is 180 degrees, correct? Still we are not done because we had a circle, we had a cyclic quadrilateral, that is A, B, C, D. As of now we have proved that the measure of angle BAD plus measure of angle BCD is equal to 180 degrees. Now what is sum of all angles of a quadrilateral? We know that the sum of the all angles of quadrilateral is 360 degrees. So we can say by angle sum property, of quadrilaterals, we can say that measure of angle BAD plus measure of angle ABC plus measure of angle BCD plus measure of angle ADC is equal to 360 degrees. But we have already proved that measure of angle BAD plus measure of angle BCD is already 180. So here can I write down 180 plus measure of angle ABC plus measure of angle ADC is equal to 360 degrees. So if I take 180 on the other side, can I say measure of angle ABC plus measure of angle ADC is equal to 360 minus 180, that is 180 degrees. So in both the cases here, we have proved that A plus C is 180 and B plus D is also 180. So B plus D is also 180. You can prove it by this way also. It's not compulsory that you have to do it in this way. This figure is given, no problem at all. We can still do it. How are we going to do this? See, this is X. So can I say C is half of X? Correct? This is Y. So can I say A is half of Y? A is half of Y. C is half of X. Now how much is X plus Y? Can I say X plus Y is 360 because it is a circle? So if I multiply by half on both the sides, so I get half of X plus half of Y is equal to half of 360, which is 180. But how much is half of X? Half of X is C. So I get C plus. How much is half of Y? Half of Y is A. So A plus C is 180. You can do that. That's your choice. And this we have done by inscribed angle theorem. Same thing. It doesn't matter. You can go with any of the two methods. Perfect. Let's continue further. So here we have a new question. It's a bit lengthy, a big question. It says, in the figure, segment AB and segment AD are tangent segments, correct? So segment AB and segment AD, they are tangent segments drawn to the circle with center C from an external point. We are supposed to prove that angle A, we are supposed to prove that this angle A is equal to half of measure of arc BYD. So this is arc BYD minus measure of arc BXD. This is what we are supposed to prove, correct? Okay, so let's begin with the proof. Now if you observe very carefully, we are going to focus on angle A. But before that, can I say CB is perpendicular to AB? Can I say CB is perpendicular to AB? That is, can I say angle B is 90 degrees? Similarly, can I say CD is perpendicular to AD? Can I say CD is perpendicular to AD? That means, can I say angle D is 90 degrees? So in both the cases, what is the reason that you will write down? We'll write down tangent is perpendicular to radius, right? Tangent is perpendicular to the radius at the point of contact. Okay. So if I take the quadrilateral, can I say in quadrilateral ABCD, can I say angle A plus angle B plus angle C, this is A, B, C, D, plus angle D, this is equal to 360 degrees. What is the reason? The reason is angle sum property. Angle sum property. Whose angle sum property? Angle sum property of quadrilateral, right? Okay, so this is the angle sum property of quadrilateral. Now understand. But we know that B is 90 and D is 90. So let us put that. So can I say angle A plus 90 plus angle C plus 90 is equal to 360. Angle A plus angle C, 90 plus 90 is 180, is equal to 360. So if I take 180 on the other side, can I say angle A plus angle C is 360 minus 180. So can I say angle A plus angle C is equal to 180 degrees, correct? Okay. Now see, angle C is this angle. So can I say this angle C is nothing but equal to BXD, correct? Angle C is nothing but BXD. We know that angle C is equal to, or I can say measure of angle C is equal to measure of arc BXD, because central angle, right? Central angle is equal, right? Equal to its corresponding minor arc, right? Corresponding arc or minor arc. So instead of angle C, can I write down angle A plus angle C? Can I say angle C is nothing but measure of arc BXD, and that is equal to 180 degrees. So as of now, what do you have? You have angle A plus measure of arc BXT is equal to 180 degrees. Okay, now understand. So if I shift measure of arc BXT to the other side, I get angle A is equal to 180 minus measure of arc BXT. Now this is an important result. So I am writing down angle A is equal to 180 minus measure of arc BXT, correct? Now understand. Now this is BXT. Can I write down the measure of arc BXT as entire circle minus BYD? So this BXT can be further written as angle A is equal to 180 minus measure of arc BXT, that is measure of circle, correct, minus measure of arc BYD. So that is equal to 180 minus 360, correct? 360, and this is minus measure of arc BYD. So this becomes angle A is equal to 180 minus 360 plus, correct, 180 minus 360 plus measure of arc BYD. But this is 180 minus 360, and how did we get plus here? This is because of this minus and this minus, it became plus, correct? Now this becomes minus 180, so can I say angle A will be equal to minus 180 degrees plus measure of arc BYD. Okay, so from here if you see, if I take minus 180, so can I replace minus 180 by minus angle A? See, understand this very carefully. See this step. Here in this step, if I take minus 180 over here, that becomes minus 180 over here, means after taking 180 over here, you will get minus. A comes to that side, that becomes minus A minus measure of arc BXT. This can be replaced here. So can I say angle A is equal to minus of angle A minus measure of arc BXT plus measure of arc BYD. Now you take minus A on the left hand side. So can I say angle A plus angle A will be equal to, write down the positive thing first, that is measure of arc BYD, then minus measure of arc BXT. Angle A plus angle A is how much? 2 times angle A, correct? Finally, can I say 2 times angle A is equal to, this is 2 times angle A is equal to measure of arc BYD. This is arc, please remember. This is BYD arc minus measure of, again, arc BXT. So angle A will be equal to You take 2 down, it becomes 1 by 2 measure of BYD arc minus measure of BXD, and hence we have proved it, right? I hope this is clear to all of you. Simple. We have proved that this angle is the difference of this arc and this arc. Perfect. Let's continue. Okay, a one marker, very easy. So chords AB and CD of circle intersect inside the circle at point E. So what is given? It is given that AE is 4. Then what else is given? EB is 10. Correct. Then CE is given as 8. We are supposed to find out AD. So by theorem on intersecting chords, right? Intersecting chords. This is simple, isn't it? We can write this as AE into BE, right? AE into BE is equal to CE into DE. So AE is how much? AE is 4 into BE. BE is how much? 10 is equal to CE. CE is how much? 8 into DE. So what will be DE? DE will be equal to 4 into 10 divided by 8. Correct? So that gives you 4 ones are 4 twos are 2 ones are 2 fives are. So we can write down DE is equal to 5. That's it. We got the value of D. Theorem on intersecting chords. So two chords, if they intersect inside the circle, then this is how we can represent it. If they intersect inside the circle, there is a condition for intersecting outside the circle also. So if this point E is outside, doesn't matter. It remains the same. Two chords intersect outside the circle. Correct? Okay. So easy question. If the radius of the circle is 5 centimeter, then find the length of the longest chord. Okay, so radius of the circle is 5 centimeter. This is a simple 6th or 7th grade question, you can say. So radius is given. Radius is how much? 5 centimeter. Correct, but you have to write down systematically. Radius is 5 centimeter. And then find the length of the longest chord. Okay, length of the longest chord. We know that longest chord is what? Longest chord is the diameter. We know that longest chord is the diameter. And we know that diameter is 2 times radius. Therefore, diameter will be 2 and 5. That is equal to 10 centimeter. So 10 centimeter is the length of the longest chord. So first you always mention there. Mention what? The longest chord of the circle is nothing but the diameter. Once you get the diameter as the longest chord, diameter is double of the radius. Radius is given. You can easily find out the diameter. Perfect? Okay. So next question is an activity based question. It was asked for 2 marks in the year 2023. So let us see what the question is. So in the above figure, angle L is 35 degrees. So angle L is how much? 35 degrees. We are supposed to find out the measure of arc MN. We are supposed to find out the measure of this particular arc. And then we are supposed to find out the measure of arc MLN. Now this is simple. So before starting with the activity, let us solve it on our own. So this is given angle MLN. Angle MLN is equal to 35 degrees. This is given, correct? So can I say angle MLN is half of measure arc MN? And what is the reason behind this? The reason behind this is inscribed angle theorem. Correct? So as per inscribed angle theorem, MLN, which is 35. So can I say 35 is half of measure arc MN? So can I say measure arc MN is 35 into 2, 70 degrees? Correct? So I get this arc as 70 degrees. And once I get the measure of this arc, now can I find out the measure of arc MLN? Now we know that measure of arc MN plus measure of arc MLN is 360 degrees, because this gives us measure of a complete circle. Correct? So measure of arc MN is how much? Measure of arc MN is 70 degrees plus measure of arc MLN, we don't know. And that is equal to 360. So can I say this is now 360 minus 70? That's it, you got the answer. So we'll say measure of arc MLN is equal to 360 minus 70. Correct, that is 290 degrees. So yes, 290 degrees is the answer for this. Correct? I hope this is clear. So this was the activity based question. Firstly, we were supposed to find out measure of arc MN. So angle L is half of this inscribed angle theorem, but L is already given. So here you will write down 35. 35 is half of MN. Cross multiply, you get MN. 2 into 35 is equal to MN. So measure of arc MN is 2 into 35. That is 70 degrees. Correct? So this is 70 degrees. And then we focus on MLN. Now see, this measure of arc MLN remaining is the entire circle, that is 360 degrees. So that is 360 minus 70, which is 290. That's a 2-mark question, 1 mark each, 1 mark for this, 1 mark for this. मैसेज टू दी एडिटर, ये सब हटा दो, ये ख़त्म हो चुका है प्रॉब्लम यहाँ पे, इस सब की ज़रूरत नहीं है, पूरा ये भी नहीं. Alright then, let's have a look at a new question now. It says, in the given figure, points G, D, E, F are points of a circle with center C. Basically they are on the circle, you can say, with center C. C is the center of the circle. And measure of arc DGF, this measure of arc DGF is 200 degrees. ECF, measure of angle ECF, this is 70 degrees. And measure of arc DGF, so where is that? DGF, okay, that's already 200 and this is 70, fine. So we are supposed to find out measure of arc DE, that is this, and then we are supposed to find out measure of arc DEF. DEF is entire this. So let's focus on solving it first. The given information is already here. Now see, this is 200. Angle ECF is the central angle. So can I say angle ECF is equal to the measure of this arc? Angle ECF is equal to the measure of arc EF, because central angle is equal to the measure of corresponding arc, right? Measure of central angle is equal to measure of the corresponding arc. So can I say measure of arc EF is equal to 70 degrees. Notice carefully, this part becomes 70, this is 200. Can I find out the remaining part now? So can I say measure of DE, plus measure of EF, I'm talking about the arcs here, plus measure of DGF is equal to 360, because this completes the circle. But DE we don't know. So can I say measure of DE plus EF is how much? EF is 70 plus this is 200 is equal to 360. So 70 plus 200 is 270. So can I say measure of DE is equal to, this is 270, this is 360, all you need to do is subtract. So you get 360 minus 270 which is 90. So this particular is 90 degrees. So we got this one, right? Measure of arc DE is 90 degrees, right? Now see, DE is 90, this is 70. Can we find out measure of arc DEF? Arc addition property. Measure of arc DEF. DEF is something that we are supposed to find out, right? DEF, see here. That will be equal to measure of arc DE plus measure of arc EF. The reason is arc addition property. Correct? Just add it. You will have 90 plus 70 and that is 160 degrees. Correct? So this entire angle, or you can say this arc rather than saying angle will be this, is 160 degrees. Perfect. So let's have a look at a new question now. So it says that prove that angles inscribed in the same arc are congruent. So we are supposed to prove that angles inscribed in the same arc are congruent. So which angles are inscribed here? How do we come to know? Yes. So understand this very carefully. What is given? It is given that there are two angles, angle PQR and angle PSR. They are inscribed in this arc, PQR, PSR. They are inside this, right? So angle PQR and angle PSR are inscribed they are inscribed in arc PQR, right? They're inscribed in arc PQR. So angle PQR and angle PSR, they are inscribed in arc PQR. Okay. Now understand. Since they're inscribed, can I say PXR is the intercepted arc for them? Yes. What are we supposed to prove here? We're supposed to prove that these two angles are equal. That is, angle PQR is equal to angle PSR. This is what we are supposed to prove. Let's begin with the proof. Can we say PQR is inscribed angle? PQR is inscribed angle and PXR is intercepted arc. So what is the relation between inscribed angle and intercepted arc? Inscribed angle is half of intercepted arc. So can I say angle PQR is equal to half of measure arc PXR. This is because of inscribed angle theorem. So this angle is half of this arc. Similarly, can I say angle PSR is inscribed angle? And arc PXR is intercepted arc. Here can I say angle PSR is equal to half of measure arc PXR. Now observe these two statements, 1 and 2. On the right hand side, we have half of arc PXR, half of arc PXR. So if I call this as 1 and if I call this as 2, can I say from 1 and 2, angle PQR is equal to angle PSR. This is from 1 and 2. And the reason for this is also inscribed angle theorem. I hope this is clear to you. Very simple. This is half of this. This is half of this. So both are equal. Even if I take an example, this is 100 suppose. This becomes 50. This also becomes 50. And they both become equal. Right? Even if you draw one more like this, this will be 50. This will be 50. And so on. Perfect. So let's have a look at a new question now. It says, a circle touches side BC at point P. So there is a circle that touches side BC at point P of triangle ABC from outside of the triangle. Okay. So there is a circle and that touches side BC. You can see side BC from outside of the triangle at point P. At point P. So further, extended lines AC and AB are tangents to the circle at point N and M. Point N, we have point M, correct? We are supposed to prove that AM is half of perimeter of triangle ABC. This is an interesting question. AM is half of perimeter of triangle ABC. Now what is the meaning of perimeter? Perimeter is sum of all the sides. So indirectly we are supposed to prove that AM is half of AB plus BC plus AC, right? Okay. Firstly, if you see this particular circle, let's begin with the proof. If you see this circle, can I say point B lies in the exterior? Point B lies in the exterior, correct? And BP and BM are tangents. Can I say BP and BM? They are tangents. So what is the relation of the tangents drawn from the external point? We know that the tangents drawn from external point are equal. So can I say BM is equal to BP because tangents drawn from external point or exterior are equal, right? Tangents drawn from the exterior point are equal, so BM is equal to BP. Similarly, if I check, that means I got BM is equal to BP. Similarly, can I say CP is equal to CN? So I can write down similarly. CP is equal to CN, right? CP and CN are equal. Now let's talk about perimeter of triangle ABC. What is perimeter of triangle ABC? What is perimeter of triangle ABC? Can I say perimeter of triangle ABC is nothing but AB plus BC plus AC, correct? This is nothing but sum of all sides. So I'm keeping this statement aside because we need perimeter. I have taken the perimeter, kept it aside. Now understand. Now firstly, can I write down this AB as it is, then BC as BP plus PC? This BC can be broken down into BP plus PC. So this can be written as AB plus BC can be written as BP plus PC plus AC as it is, correct? But observe, can I say this BP is equal to BM? So instead of BP, can I write down BM? So this becomes AB plus BM plus PC. So that is PC. But what is PC equal to? PC is equal to CN. So can I write down PC as CN plus AC? Now understand this. This is AB plus BM. AB plus BM. That becomes AM. So here I can write down AM plus AC plus CN. AC plus CN. Can I write down AN? So the result that I have right now, is perimeter of triangle ABC is equal to AC plus AM, AN plus AM. Now see, there is a circle. There is point N here, there is point M here, and there is point A here. So can I say AN and AM are equal? Can I say AN is equal to AM? Because tangents drawn from external point are equal. Correct? Tangents drawn from external point are equal. So instead of AN, can I put AM? Yes. So can I say perimeter of triangle ABC is equal to AM plus AM, and AM plus AM is 2AM. So 2AM is equal to perimeter of triangle ABC. So can I say AM is equal to half of perimeter of triangle ABC, and this is exactly what we wanted to prove, isn't it? So if you see this one, in this particular question, we are supposed to prove that AM is equal to half of perimeter of triangle ABC. So I hope you have understood this question, easy. So let's have a look at new question, which is an MCQ based question. So it says a circle having radius 3 centimeter. If a circle is having radius of 3 centimeter, then the length of the longest chord is what? This is a simple question again, right? So a circle having radius how much? 3 centimeter. No need to draw the figure also. Longest chord. What is the longest chord? We know that longest chord of the circle is a diameter, and diameter is nothing but 2 times radius. So if radius is 3 centimeter, diameter will be 2 into 3, that is 6 centimeter. So that's it. 6 centimeter is the right answer. So we can say that the length of the longest chord is 6 centimeter. Correct? Sometimes they can give you the length of the longest chord and they can tell you to find out the radius. So in that case, you have to half it. For example, length of the longest chord is 5 centimeter. What is the radius? The radius is half of 5, which is 2.5 centimeters. Okay, so the new question says two circles of radii 5 centimeter and 3 centimeter touch each other externally. So they touch each other externally. So how does the figure look like? Two circles, circle 1, circle 2. Don't write down the answer directly. So there are two circles with circle center A and center B touch each other externally at say point P. Correct? Okay. So the radius of the first circle is 5 centimeter. Radius of the second circle is 3 centimeter. You know the answer directly, it is 8. But don't write down directly because you have to give the reason why we are adding that. So this is by theorem on touching circles, right? By theorem on touching circles, A, P, B are collinear, right? Therefore, we can say that AB is equal to AP plus PB. So that is equal to 5 plus 3, that is equal to 8. So now we can say that the distance between the two centers is 8 centimeter. You can also write down R1 plus R2 if you want. The distance between the centers is equal to the sum of the radii, which is 5 plus 3. Both the ways are correct. But in both the ways, this is something important, this part. You have to write this down, otherwise you won't get that 1 mark. Because direct addition is not possible. They can be like this also, no? So why they are straight? Because of this theorem on touching circles. Correct? So let's have a look at a new question now. It says, in the figure, measure of arc NS is given 125 degrees. So this NS is 125. And measure of arc EF is also given 37 degrees. We are supposed to find out the measure of angle NMS. See, again there are two ways. One of the ways is you join this and then solve. But let's go with the other way. So two chords. Can I say chord any and chord, you can also call them as secants basically, SF intersect, right? But they intersect externally. They intersect externally at point M. Correct? They intersect externally at point M. Therefore, we know that, so by this particular theorem, that is theorem of intersecting chords, we can say angle NMS, we have already proved this if you remember, is half of the measure of arc NS minus measure of arc EF, right? So this is equal to half of measure of arc NS is 125 degrees minus 37, right? So that further becomes measure of angle NMS is equal to half of, it was 125 minus 37. So 125 minus 30 is 95, 95 minus 7 is 88. So half of 88, right? And half of 88 is 44 degrees. So this particular angle is 44 degrees. There are multiple ways of doing it. Just a short way again. In case if you don't remember this formula, how do you do this? You join ES. This is 120, how much it was? 125, okay. This was 125 and this was 37. If this is 125, this will be half of 125. That is 125 by 2, this angle. And if this is 37, this angle will be 37 by 2. This angle will be 37 by 2. Now we know that this angle is the exterior angle for this triangle. So to find out this angle, that is angle NMS, that will be equal to this angle, exterior angle, which is 125 by 2 minus 37 by 2. See, you're getting the same thing. That is 88. Correct, by 2, and that gives you 44. Easy? Okay. So let's have a look at one last question. It says chords AB and CD of a circle with center I intersect at point E. Okay, with center I or center P, doesn't matter. To prove AE multiplied by EB is equal to ED multiplied by CE. There is a construction, draw AC and BD. Basically we join that. See what is given. If you see, there is a circle given and there are two chords. One is chord AB, other is chord CD, and they intersect at point E, right? Correct. And we are supposed to then prove this, that A into EB is equal to C into ED. For that we are joining this and we are joining this. Correct. It's simple. So let's again firstly do it on our own. So how do we prove this? We'll begin with the proof. We'll firstly prove the two triangles similar. So can I say in triangle AEC and triangle DEB? In triangle AEC and triangle DEB, can I say this angle and this angle will be equal? Why they will be equal? Because if you see, there is a circle and it's like this. So this is the intercepted arc. This angle and this angle will be equal. Correct? Angles inscribed in the same arc are equal. So angle ACE is equal to angle DBE. What is the reason? Angles inscribed in same arc. Correct? Not only that, can I say these two vertically opposite angles are equal? Angle AEC is equal to angle DEB. Correct? Why? Because they are vertically opposite angles. And we know that vertically opposite angles are always equal. Now can I say the two triangles are similar? So I can say triangle AEC is similar to triangle DEB. Why? By AA test of similarity. So since they are similar, can I say the corresponding sides are in proportion? So can I say AE by DE, AE by DE, AE by DE is equal to EC by BE or CE by BE. And the third one is AC by DB, which is not needed. If you cross multiply here, what do you get? You get AE into BE is equal to DE into CE, and you have proved this, right? So this is how you prove it. Easy. So let us see this now and let us try to fill in the boxes here. Okay. So as we know, the construction is already joined these two. We'll try to prove the two triangles similar now. Angle AEC, okay, AEC is equal to angle DEB. We're supposed to write down the reason. What was the reason for that? Vertically opposite angles, right? This is vertically opposite angles. Okay, now this is interesting. Two angles which are angles inscribed in same arc. There are two choices. Either you can take angle A is equal to angle D because for them they have same intercepted arc BC, or you can take angle C is equal to angle B. That's your choice. So if I take angle C, that is ACE, angle ACE, that will be equal to DBE. Correct? So the two triangles are similar. By what? AA test of similarity. Correct? And since the two triangles are similar, corresponding sides are in proportion. So if you see, here you have DE, so here you have AE corresponding. Here you have CE first and the third, then here you will have BE. What is the reason that you will write down? Corresponding sides of similar triangles, and then you cross multiply. So A into B is equal to C into D. Correct? So this completes the activity as well. So such a long chapter. I hope you have understood the concepts based on circle. This is a very important chapter from board point of view. Ample of questions will be asked. You will have 1 markers. You will have 2 markers. You will also have 3 markers in the exam. So please make sure that you practice this chapter very thoroughly and carefully. I hope you enjoyed this session. See you again in the next class. Thank you so much. Until then, keep learning with top scholars.